So we have covered a number of geosynthetic types and many geosynthetic functions. Let's put all this together. One way in which we can do this is by illustrating a case such as a waste containment facility. And this is because in a waste containment facility, we have a significant number of geosynthetics being used for essentially all the different functions. So let me walk you through that just as an illustration. So this is a skeleton of a waste containment facility, the earthen components of a facility. Essentially, the goal in this type of system is to encapsulate solid waste. And here we have at the base a clay liner that is going to be part of the barrier system. What we have in here is a series of infiltration barriers. On the cover system on the top, we will have a geomembrane that is right next to a GCL. It turns out that the combination of geomembrane and earthen liners, such as GCL, are particularly effective. At the base, we have what is called a double composite liner. The base liner and waste containment facility is critical, and that's why we have two liners. Two is better than one, but that's not the main reason. The main reason is that by having the primary liner and a secondary liner, we can monitor any leakage that may occur. Infiltration barriers fulfilled with geomembranes, which we have seen, and geosynthetic clay liners, or GCLs. In addition to these yellow infiltration barriers, we may need to stabilize many of the components in a waste containment facility, and that's when we have these green reinforcement layers. In the cover system, we have geosynthetic reinforcement on top of the geomembrane. This geogrid on top of the cover system is to provide stability against potential sliding. There is also a geosynthetic reinforcement under the liner, and this is for a different reason. The presence of this geosynthetic is to limit the straining in the liner. Also illustrated in this sketch are reinforcements in the side slopes and in the bottom of the waste containment facility. GeoGrids are a type of geosynthetic that provides the reinforcement function in this case. In addition to the yellow infiltration barriers and the green reinforcements, we need drainage layers. And here we have a series of blue drainage layers. On top of each barrier system, we will need a drainage system. On top of the geomembrane in the cover, we have a drainage layer that ends in a geopipe. And on top of each one of the two base liners, the primary liner, we will have a GEONET, and in between the primary and the secondary liners, we will have a second GEONET. GEONETs are the geosynthetics that we will use for in-plane drainage, along with geocomposites that are very common because they provide not only in-plane drainage, but also the important function of filtration. And in addition to the yellow barriers and the green reinforcements and blue drainage, we have the pink separation layers or protection layers. And these are going to provide the erosion control on the cover system and all the component of the carrier for GCLs. And for these functions, we're going to have GEOTEXTILES and erosion control products. So here we have an example in which we have multiple geosynthetics fulfilling the many functions that geosynthetics can fulfill. And also, as a final exercise, let's go over the different geosynthetic types: geotextiles, geogrids, geomembranes, geonets, geocomposite drains, geocells, GCLs, and erosion control products. And the goal in here is to identify for each one of these geosynthetics, what are the functions that they can fulfill: separation, reinforcement, stiffening, filtration, barrier, drainage, and protection. I'm going to give you a few minutes to complete this on your own, and then we'll do it together. Okay, so geotextiles, they can provide separation and they can provide reinforcement, woven geotextiles, and can provide stiffening and can provide filtration. Barrier, this is a difficult one. I'm including it here, but in yellow because it's not trivial. Geotextiles are pervious geosynthetics, but when they are under unsaturated conditions, they can provide what is called a capillary barrier. But it can provide also some form of in-plane drainage and certainly protection. GeoGrids, they can provide mechanical improvement in the form of reinforcement and stiffening. And geomembranes, they can provide hydraulic barrier and GEONETS in-plane drainage. Geocomposite drains, both in-plane drainage and filtration. Geocells, they can provide reinforcement. It's stiffening, for example, if we use them to stabilize a road base. They can provide protection. In this case, I'm putting as protection the erosion control. GCLs, certainly a hydraulic barrier. I'm also showing it as protection in yellow because it's not an obvious one. The reason that I have it as protection is because GCLs are very commonly used in combination with a geomembrane to form what is called a composite liner. And in this case, the GCL can provide protection to the geomembrane. An erosion control product that we identify these as being a protection function. In summary, geosynthetics are geomaterials. The number of geosynthetics is large and is continuously growing. Geosynthetics are engineered materials, and as such, we need to identify their properties and we need to design for them. The properties of geosynthetics are selected according to their functions. There are many additional sources where we can learn more about geosynthetics. This includes the International Geosynthetic Society, the IGS, the national chapters of the IGS. And by the way, student membership in the national chapters is generally a free membership. Geosynthetic Institute, based in Philadelphia, the Geosynthetic Manufacturer Association standards organizations such as ASTM and ISO, and sister organizations such as Erosion Control Technology Council, ECTC. So in summary, we have gone over the different geosynthetic types and the different geosynthetic functions. This is a very dynamic area of geotechnical engineering, and we expect continued growth in the area of geosynthetics.